Good morning, sir. We are from Group 5. The members are Emeninta Angelina N.P, Fitri Amalia, and Muthia Damayanti. We will explain about visual media with the topic electric and magnetic field. The first, I will explain definition of visual media. Learning objective. Students can understand the definition of visual media. Pictures or photos are the most commonly used media. Visual media is a medium that conveys messages using visual communication with the sense of sight. The Chinese proverb says that a picture speaks more than 1,000 words, said Sadiman. Learning objectives. First, students understand the requirements of good visual media. Second, students can make media that is easy to use, cheap, attractive, and effective. Good visual media requirements. First, easy to use. This visual media must be easy to use by all students, which doesn't only focus one target, and teachers can use it without having to do very long training on the media. Second, easy to produce. This media should be easy to produce and not expensive. For example, take a picture from used magazine and then cut it out. Third, effective. What media is depicted must be quite important and suitable for the thing being studied or the problem at hand. The picture must be true or authentic, meaning that it describes a similar situation when seen in the actual situation in order to achieve a teaching. Fourth, interesting. This medium must be attractive, elegant, and economical. With the right color adjustment, it will create a more attractive impression. Although color cannot absolutely increase the value of an image, color can clarify the meaning of what is depicted. Learning objectives. First, students can understand learning through media. Second, students analyze a phenomenon using media. Third, students apply media to learning. Good visual media requirements. Fifth, in accordance with the learning objectives, using visual media is more practical in teaching. When we give students an image, it is easier for students to relate one thing to another. Besides that we can arrange topics that match the image more easily. 6. Stimulate students. With this media, it will make students more active. Students will be able to carry out activities because students not only listen but can also observe, demonstrate, act out, and ask questions to the media. The seventh, helpful. Using useful visual media so that learning objectives are achieved. Don't create a visual medium but never use it. And also, in making the media must also pay attention to its shape, not too small, so that students can understand the media clearly and realistically.
The first material in physics is about electricity. Learning objective in this material is first, students understand how electric current can flow. Second, students can apply in life any phenomena that touch and conduct electric current. Third, students can analyze how electrical energy can be transformed into other forms of energy. Electric charge is classification into two types, positive charge and negative charge. Similar electric charge will repel and dissimilar electric charge will attract. Electricity is a form of energy that can be easily changed to other forms. We usually see the phenomena in our surrounding, that is thunderstorm. Thunderstorm is the collection of the clouds from a large cloud so that there is a friction between the one cloud and another. This friction causes the electric to move freely to form a frictional electric charge that descends from the clouds to the ground to be neutralized. The electrons in the shell closest to the nucleus have a strong force of attraction to the protons. Sometimes the electrons in an atom's outermost shell do not have a strong force of attraction to the protons. These electrons can be pushed out of their orbits. Applying a force can make them shift from one atom to another. These shifting electrons are electricity. The next topic is about Coulomb's law, electrical potential energy, and electric potential. Learning objective of this material is about first, students can understand the formula of the equation from Coulomb's law, electrical potential energy, and electrical potential. Second, students can apply the equation formula from Coulomb's law, electrical potential energy, and electrical potential in the problem. And third, students can analyze the problem itself. Does it want the equation or formula from Coulomb's law, electrical potential energy, or electrical potential? Material about Coulomb's law. The interaction of like electrons charge will repel, while different kinds of charge will attract. Coulomb's law have equation where the V21 is equivalent with V21 is equivalent with K times Q1 times Q2 per R to the power of 2, where the V is Coulomb force with the unit of Newton, K is Coulomb's constant with the equivalent is with 9 times 10 to the power of 9 with the units of Newton meter square per Coulomb square, and Q1 is the electric charge on object 1 with the unit of Coulomb, and Q2 is the electrical charge on object 2 with the unit of Coulomb, and R is the distance between the object with the unit of meter. And the electrical potential energy is the work done by the Coulomb's force to move the plus Q test charge from one point to another. The electrical potential energy have equivalent, that is EP is equivalent with K times BQ times Q bar per R, where the A is electrical potential energy with the unit of joule, BQ is the surge load with the unit of Coulomb, and Q bar is the test charge with the unit of Coulomb. And the electrical potential is the potential energy per unit charge, where it's given the equivalent V is equal to K times Q per R, where V is the electrical potential with the unit of volts, Q is the surge load with the unit of Coulomb, and R is the distance from charge to the point P. The next material is about Ohm's law, Kirchhoff's law 1, and Kirchhoff's law number 2. Learning objective of this material is about first, student can understand the formula of the equation from Ohm's law, Kirchhoff's law number 1, and Kirchhoff's law number 2. Second, student can apply the equation formula from Ohm's law, Kirchhoff's law number 1, and Kirchhoff's law number 2 in the problem. And third, students can analyze the problem itself. What information does it have? In Ohm's law, we have the equation where the V is equal to E times R, where the V is the voltage with the unit of volts, E is the current with the unit of ampere, and R is the barrier or resistance with the unit of omega. Kirchhoff's law number 1 gives the equation where the current entering the node equals to current leaving the node. And Kirchhoff's law number 2 have the equation where the resultant of V drop is the resultant of V rise. The algebraic sum of the voltage drops in a closed circuit or loop in a given direction is equal to algebraic sum of the voltage rise. And the next topic is about resistor series circuit and resistor parallel circuit. Learning objective of this material are: first, students can understand the formula of the equation from resistor series circuit and resistor parallel circuit. Second, student can apply the equation formula from the resistor series circuit and resistor parallel circuit in the problem. And third, student can analyze the things that have resistor series circuit and resistor parallel circuit existing in the surrounding environment. In resistor series circuit, a breaks in any parts of the series circuit stop the flow of current in the whole circuit. It gives equation where the R total is equal to R1 plus R2 plus Rn. And in the resistor parallel circuit, if a component breaks or is removed, the other components remains on. It gives equation where the 1 per R total is equal to 1 per R1 plus 1 per R2 plus 1 per Rn.
The next it is discussed about magnetic, which is the learning objective is students are able to describe and understand the meaning of magnetic. So there are two pictures here. There are refrigerator and two magnetic. Have you ever seen or even had decorations stuck to the refrigerator door? Why is the decoration sticking and not falling? But when it's paper or wood, why not stick it, right? Well, the decoration that can stick is called a magnet. A magnet is an object that can attract other objects from certain materials. Every magnet must have two places where the magnetic force is strongest, namely the magnetic poles. The magnetic poles are usually at the ends of the magnet and have the greatest attraction or repulsion. There are two poles of a magnet, namely a north pole or U and a south pole or S. For an explanation of the two magnetic poles, it will be discussed in the next material. There are three learning objectives here. Number 1, students know the state of the magnet for similar and dissimilar. Number 2, students know the magnetic field caused by electric current. Number 3, students know the discussion and results of the Oersted experiment. And then there is a picture or a figure that shows about magnetic lines. Magnetic lines of force are the direction of the magnetic field in the form of lines connecting the magnetic poles. Magnetic lines of force always start from the north pole of the magnet and enter the south pole of the magnet. And next, magnetic field around or due to electric current. Oersted states or determines that the presence of a magnetic field around a current carrying wire. There are three conclusions that he made. The first is the wire is not electrified. The needle magnet remains in its original north-south position. The second, the wire is electrified from the south. The needle magnet deviates to the left. The third, the wire is electrified from the north. The magnetic needle deviates to the right. Oersted in 1820 shows that magnets can be generated by electric current. So we can see from the figure that magnetic field creates a force on the current. And then Oersted also proposed the right-hand rule, where the thumb indicates the direction of the electric current, while the forefinger grip indicates the direction of the magnetic field. There are two learning objectives here. The first is students know the formula for the force on a magnetic field by looking at the graph. The second, students know the magnetic force on a current carrying wire. The first figure, we can see about an electric current element. There are three variables here. Those are F is force, I is electric current, B is magnetic field. And then from the graph we can see that the formula of this is GF equals I times dl times B. This formulation is often considered to the definition of the magnetic field. If the current is constant in a uniform field, then F equals I times L times B. But when in the problem it is known about the angle, we can use the formula absolute value of F equals I times L times absolute value of B sin theta. The second figure, we can see about the magnetic force on current wire. This is using about right hand rule. This also use three variables. They are F is force of magnetic, B is magnetic field, I is electric current, and L is length. The formula is F magnetic equals I times L times B. Or if in the problem it is known about the angle, we can use F magnetic equals I times L times B sin theta. The other formula about the magnetic field is using integral. The next figure is about want to find the formula of magnetic field or B. First, it is using the closed curve integral. The closed curve integral B times ds equals mu naught times I, which is B times ds equals the absolute value of B times the absolute value of ds, which is the absolute value of B is constant. The curve closed integral B times ds equals 2 times P times R times B. So we can get the formula of the magnetic field B from the equation before. B equals mu naught times I over 2 times P times R. Or we can write B to P times B equals mu naught times I. Or B equals mu naught times I over 2 times P times R. Last is about the magnetic field around a current carrying wire. You can see the figure of triangle here, which has A is a front side, R is hypotenuse, and there is the vector of R, and then the distance ds or x. The formula that we can get from this figure is the first tan theta equals negative A over x, and sin theta equals A over R. One, students can analyze the magnetic field in a current carrying wire. Number two, students being able to understand about Lorentz force. The first figure, we can see the magnetic field in a wire with a current of I-O. The formula is I equals A in lowercase over A in uppercase times I-O or I0 equals by PR square over PR in uppercase square times I0 equals R in lowercase r square over R in uppercase R square times I0. The sigma B times ds equals 2 times P times R times B equals mu naught times I. We have been gotten the value of B, or the formula of B is equals mu naught times I over 2 times P times R. We can get B is equals mu naught times R in lowercase over 2 times P times R, in uppercase square times I0. Next is about the magnetic field around a long current carrying wire. So this also has two formulas here. The first formula of magnetic field is mu null times R in lowercase over 2 times P times R in uppercase square times I0. Or it can be written by B equals mu null times I0 over 2 times P times R. The magnitude of the Lorentz force F experienced by a conductor of length L carrying an electric current I in a homogeneous magnetic field B and forming an angle to B. For an electric charge Q moving with velocity V in a homogeneous magnetic field B. Picture we can get I equals Q over T. Then I times L equals Q over T times L equals Q times V. So that we get the formula F equals Q times V times B in test charge positive Q from the graph. The final formula of Lorentz force is F equals B times Q times V sin alpha. A current carrying or electrically charged conductor moving in a homogeneous magnetic field experiences a Lorentz force.
That's all about our presentation. Thank you for your attention, sir.